Welcome to our Knowledge Bank series, where we share detailed information about major pollutants in the atmosphere. Today, let's talk about one of the most dangerous culprits we encounter daily. Let's talk about PM2.5. Have you ever noticed how some days you step outside and the air feels thick and heavy? That's not just dust, it's something much smaller and more dangerous. It is particulate matter, also called PM2.5. So what is PM2.5? PM2.5 refers to tiny airborne particles that are 2.5 micrometers or smaller in diameter, about 30 times smaller than the width of a human hair. Because they are so small, you can't see individual PM2.5 particles with the naked eye, but they can make the air look hazy or smoky when present in large amounts. Once in the air, PM2.5 can travel for days, covering hundreds of miles. It's one of the most dangerous types of air pollution. So many governments set rules to keep it under control. So, where does PM2.5 come from? Let's talk about its sources. We often picture factories and construction sites when we think about air pollution. But the truth is that particulate matter, or the harmful PM2.5, comes from various sources. These tiny particles can either be directly released into the air, known as primary sources, or form in the air through chemical reactions between gases like sulfur oxides and nitrogen oxides, which are secondary sources. PM2.5 is also generated through natural sources like marine aerosol, soil erosion, volcanic eruptions, and forest fires. Human-made sources also contribute to PM2.5 emissions, and they are known as anthropogenic sources. Burning fossil fuels, agricultural processes, cooking and cigarette smoke, emissions from motor vehicle exhaust, specifically diesel-powered, and emissions from power plants and industrial combustion processes are some of the human-made sources of PM2.5 emissions. Whether directly emitted or created in the air, it has the same impacts that affect our health and environment. Let's clearly and simply understand how it impacts human health and the environment. At first, it might sound simple. Just tiny dust particles, right? But it's much more than that. PM2.5 carries toxic chemicals and heavy metals that affect the air quality, health, and the environment. PM2.5 is so tiny that it can reach our lungs and bloodstream, leading to asthma, heart disease, and lung issues. Long-term exposure increases the risk of heart attacks, asthma attacks, and even premature death, which is especially dangerous for children, the elderly, and those with heart or lung conditions. It also harms the environment by disrupting climate patterns, reducing visibility, and impacting global temperatures. PM2.5 particles also settle on plants, soil, and water, damaging ecosystems and reducing plant growth. To prevent such damage, it is crucial to monitor these tiny airborne particles and work towards reducing their presence in the atmosphere. Let's talk about what measures we can take to protect ourselves from PM2.5 exposure. The first step is to monitor the air quality. Regularly checking AQI readings helps us spot high pollution levels so we can take precautions. Limit outdoor activities, keep windows and vents closed, and skip exercise if AQI exceeds safe limits. A pollution mask can also help when outdoors. Skip the fireplace or gas-powered tools indoors. Eat antioxidant-rich foods like berries, nuts, and greens. Avoid high-traffic areas or construction zones. Taking these small steps can make a big difference in reducing your exposure to harmful PM2.5 particles. But how do we accurately measure PM2.5 around us? Let's explore how air quality monitoring systems detect PM2.5. There are several methods to monitor PM2.5 in the air, each with a unique approach to measuring particulate matter. Let's break them down. Gravimetric method. This traditional but highly precise method collects air particles on a filter over a 24-hour period. The weight difference before and after gives a reliable measure of PM1 concentration. Beta attenuation monitor (BAM). This method uses beta radiation to detect how much is blocked by collected particles. The more the blockage, the higher the PM1 concentration. Laser scattering, a modern real-time technique where laser light is scattered by particles, helping determine their size and quantity instantly. Tapered element, oscillating microbalance, TOEM. It continuously weighs particulates as they build up on a filter. The more particles that collect, the less the filter vibrates, allowing us to measure PM2.5 levels in real time. By learning more about it, monitoring it, and taking small steps to reduce our exposure, we're not just breathing easier, we're investing in healthier communities, a cleaner planet, and a better future. We hope this gave you a deeper understanding of PM2.5 and why it truly matters. If you have questions or want to explore more, we're always here to help. Stay informed, stay safe, and keep breathing clean.